Hello student, this video is for SEE students. In this video I am going to solve the question which is on your screen, and okay, let's start it. The question is, find the separate equations represented by given equation x square minus 2xy cosec a plus y square is equal to 0. Also prove that angle between them is theta equal to pi c by 2, which means 90 degree plus minus a. There are two parts in the question, so first we have to separate the equation, the given equation, and then we have to find the angle between those separate equation. And first we have to understand the question. The question is from coordinate geometry, which is clear to everybody, and from coordinate geometry, in coordinate geometry it is from pairs of straight line. This is a homogeneous equation, which means homogeneous equation of second degree. Because of presence of 2, this whole equation is homogeneous equation of second degree, and it contains only two separate equations. Because it is of second degree, it contains two equations. We can separate we can find the separate equation from this equation by different method. We have two or three, probably more, a method to separate it. First is universal method, which is a long method also. In that method we reduce this equation, this given equation, to quadratic form, and then we compare with ax square plus bx plus c equal to 0, and then we apply the formula, and it becomes lengthy. Because this equation contains trigonometric ratio, we can use a trick here. And let's start first part. Let me write it. First part, first part is separation of first part is finding separate equation, a given homogeneous equation. Let's write given homogeneous equation is x square minus 2xy cosec a plus y square is equal to 0. Now, or x square minus 2xy cosec a plus y square dot 1 equal to 0. Y square dot 1, because if we multiply y square by 1, and the result will be y square. So these two steps are fairly same. Now let's rewind backward. In class 9 we have studied these three formula: cosec square theta minus cot square theta equal to 1, sec square theta minus tan square theta equal to 1, sin square theta plus cos square theta equal to 1. So we have our 1 here, and we have 3 1. Among these three, we are going to use the first one, cosec square theta minus cot square theta equal to 1. Why? Because in our question there is cosec a, so we are going to use the very first one, cosec square theta minus cot square theta equal to 1. Why not these two? Because we have cosec a. Cosec भएपछि cosec भएको नै फर्मुला लगाउनु पर्यो. Okay, let's use, instead of this one we are going to write cosec square theta minus cot square theta is equal to 1, or x square minus 2xy cosec a plus y square, bracket, there are two terms, cosec square a in form of a we have tried because our angle is a, minus cot square a is equal to 1, or we are going to open the bracket now, 2xy cosec a plus y square cosec square a minus y square equal to 0. Okay, sorry, minus y square cot square a equal to 0. See, instead of 1 we wrote cosec square a minus cot square a, and because the value of cosec square a minus cot square a is 1, and after opening the bracket we arrive at this position. Now see, this part of the question, only this part of the question, x square minus 2xy cosec a plus y square cosec a. Let's complete the square here. X square plus y cosec a whole square, the last part y square cot square a equal to 0 as it is. Now in between minus, we are going to complete the square. Y, let's bring x here, x. Now this part, it will come here, y cosec a. Now see here, a square minus 2ab, this part is b, plus b square, which is a minus b whole square. This is a square part, cosec a whole square, and this part we can write y cot a whole square. Now we can say this is a and this is b, which means a square minus b square, isn't it? Let's apply the formula. A plus b, a minus b, a square minus b square formula is a plus b, a minus b. A part is a plus b part is, again a part is, b part is equal to 0. Either x minus y cosec a plus y cot a equal to 0, or x minus y cosec a minus y cot a equal to 0 are required separate equation. Equations. We concluded our first part. We concluded the first part of our equation. Now for the next part, for the second part, in second part we have to find angle between them. So again let's write the given equation is x square minus 2xy cosec a plus y square equal to 0. Now we can find the angle between them by using the formula from first chapter, angle between straight lines. But here, as this is a homogeneous equation, a question from the pairs of straight line, and this is a homogeneous equation, we will compare this equation with ax square plus 2xy plus by square. Comparing with, let's write comparing with plus 2hxy plus by square. This is a standard equation of homogeneous equation. This is a standard equation which the equation passes through origin. In the case where equation passes through origin, we can apply this form. Now a is 1. A is coefficient of x square, so coefficient of x square is 1. B is also 1, so 2h equal to minus 2 cosec a, so h equal to minus cosec a. Now let's represent, let theta be the angle between, let's define our angle, let theta be the angle between lines represented by equation 1. Let's define this equation as 1. Okay, this is equation 1 represented by equation 1. So using formula, our formula is tan theta equal to plus minus 2 root under h square minus ab upon a plus b. We have everything required. 2 root under h square is minus cosec a whole square, which is the value of h, minus a is 1, b is also 1, upon a is 1 plus 1 equal to plus minus, say, 2 root under cosec square a minus 1 upon 2. This 2 and this 2 can be cancelled, plus minus, what is the formula of cosec square a minus 1, which is cot square a. Now if you cancel this one, it will be plus minus cot a, which is equal to plus cot a comma minus cot a. Here is tan theta. Now see the quadrant here. See the quadrant here. This quadrant. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. In third quadrant and first quadrant, in first and third quadrant, 10 is positive. So we are going to use for positive part 10 pi by 2 minus a. 10 90 degree minus theta is 10 90 degree minus a is cot a, isn't it? We studied this in class 9. And for negative part, what we do is 10 pi by 2 plus a, as 10 is negative in this part. In this quadrant, in second quadrant, 10 is negative, so this quadrant is 180 degree minus theta and 90 degree plus theta. We don't use this quadrant because 270 in our question it is not asked like that, isn't it? We have to prove pi by 2 plus minus a. Because of that, you can see in the question we have to prove pi by 2 plus minus a. So we are not going to this part, 270 plus theta. Now tan theta equal to here, and we should not forget to write or also, or see, or now multiplying both sides by tan inverse theta, what we get is theta is equal to pi by 2 minus a comma pi by 2 plus a. If we combine, we will get pi by 2 plus and minus a. This is a radian because radian means 180 degree, pi c 100, which is our answer, and we proved it. We concluded our solution, and hope you understand, and see you on next video.